All right, the time is now 3:25 p.m. Eastern Time. We're going to resume our technical talks. Our next presenter is David McComas, independent consultant. He will be talking to us about OpenSatKit, a flight software systems educational platform. David.
Okay, Chris, thanks. And thanks to APL and the team for putting this great conference together. You guys are doing a great job with the virtual. And I also appreciate you being in the same time zone as me. So since I live down this, not too far. I also appreciate everybody adjusting their schedule and all the talks before mine, because they've actually kind of opened the door for some of the conversation. I titled this Flight Software Systems Education, and it might be a little misnomer. I mean, OpenSatKit started as a CFS educational system, but I did the systems part because I've actually been using OpenSatKit for demonstrations in some STEM educations. But as I put this talk together, it's really also about the CFS community, and perhaps I kind of want to pose some questions during the talk, and some of it's about how can OpenSatKit better serve this community. Next slide, please. So what is OpenSatKit? It was originally developed to help with the CFS education and adoption, and also to provide application development and runtime environment. So it's and I'll get into the pieces of it. So what I've been doing is just adding functionality lately. So building up a system, but I haven't actually been organizing all towards a user's use case. So I think it's helpful, but it's not optimal right now. And I think there's also some untapped features, and that's kind of why this has been real helpful for me. And actually thinking back, some I think it was Michael Starch's the F Prime talk, embrace open source. I'm not quite there yet because it's kind of been a personal hobby and give back. But I think it's time, to grow and get contributions and see where, but that takes some orientation and see where this should go. So I'm introducing some use cases in this presentation, do it more from a user need base. And part of it, as I just mentioned, so make people aware of some of the functionality and then see where we can go from a conversation point of view. So the agenda, I'll give some more background and a little bit, introduce the CFS for anybody that's not familiar. Then I'm going to step through 4 use cases. It's a little tight on time, but we'll see if we can get through them. So the first one is, you want to learn OSK and the CFS concepts and capabilities. Second one is I want to develop a flight software CFS-based system. And third is I want to package and distribute apps. And what exists right now gets a little lighter as we go down these use cases and a little more conceptual. And then the fourth one is I want to use OSK for technology and education efforts. And what do those configurations look like? And finally, conclusion. Next slide, please. So here's the CFS architecture. Hopefully, a lot of people are familiar. So it's a 3-tiered architecture that I call a portable framework with a product line deployment. And the framework, as you can see, is that word is that word. I'm not always consistent, maybe with the other consistency, but the CFE is portable as long as the platform abstraction is ported across a platform, which is a combination of an operating system and a platform support package. And then the CFE being portable creates a portable environment for applications. And then if you're in the town hall, you learn that the CFS bundle that introduces some what are called lab apps. And those are suitable using UDP type protocol. And that together is also CM as a configuration item. And I got some links in the back with some, to get all the resources. And the product line part of it, I just, so CFE has a lot of compile time configuration parameters. And it also has runtime configuration in terms of commands and tables. So that's where I put in that's what kind of makes it adaptable and scalable. Next slide, please. So here's a product, I call it a product model, and it's not like this has been, published anywhere. So this is kind of how things are. I see them as evolving. In the bottom right left corner, you got NASA, and it's got a configuration control board that's across multiple centers and led by Goddard. And those products I just mentioned, that's the control board. And then each app provider or any tools, that's up to the individual provider. So NASA releases a bundle. I put the components specification in dashed lines because they're not really, we have guidelines, but they're not quite formal as in this is how you can plug and play. So then I call that a component supplier. And then those components are added to a distributor and you make a distribution. So, and there's been a lot of chat on the CFS Slack channel. You've probably seen, you know, like Windhover Labs has a distribution. This one is a distribution. I guess what I'd postulate to the community is, you know, where's the value proposition? What incentive do people have to be a supplier or a distributor? And what can we do to help foster that? And that's been some of the conversations all week. And my personal, I like the education aspect. So I'm doing this as this, I would consider OpenSat a distribution. And that's my personal motivation. And actually, I didn't realize this had animation in it. So if you could hit the space bar or something, next slide, I guess. I guess that'll, those are just some challenges with the CFS. And I think we've seen some of these. And, you know, Peter Feidelman gave a good talk. You know, there's a learning curve with trying to assemble the pieces and create your own system. Next slide, please. So OpenSatKit in 2015, that was a big year for open source and the flight software. So CFS was released in pieces, but in early, I think it was January, all of CFS was open source at that point. Then Ball Aerospace open source Cosmos, a command and control platform, and Goddard released the 42 simulator. So I'm very appreciative of all these efforts. Obviously, I'm, you know, standing on their shoulders, and I put all this together into an operational system. So next slide, please. Something I started last year, in June of last year, and I started making YouTube videos. And these were organized in a playlist. So there's introductory material, core flight executive, application development, and I call it system engineering. And I'll get into that a little more, what I mean by that. And then individual community apps. And there's a lot more. And again, like I said, this is not how you go through a use case. It's just a, you know, blob of material. So next slide, please. So to get started, you go to the OpenSatKit wiki, you launch Cosmos. So Cosmos is really, if you see on number 3, is just a toolbox, and it's very extendable. It's all open source, and it's written in Ruby, and it's got some, you know, it's custom owned language for designing screens and defining commands and telemetry. So that CFS button, you click on that, and next slide, please. Then you get this screen. So OpenSatKit has 3 tabs. The first one is Explore, CFE, or CFS, and SimSat. And SimSat is a pre-configured reference mission. And that gave context for organizing some of the apps and having default configurations. And I guess one other caveat here is that, you know, it's a work in progress. So everything's being matured. As I said, I'm still building up functionality. This first tab's pretty good shape for the most part. But as we get further in tabs, it also gets a little less developed. Second tab is a development. I'm thinking of it more now as an app development kit, but it doesn't have a lot of features implemented yet. And we'll see something in a second. And then the third tab was more extend OSK. And what I meant by that is, you know, I'll show a picture later about Alan Cudmore's PySat being connected to the Cosmos, and things like SBN, software bus network, or things where if people want to connect to ROS, the idea was if there could be other extensions that could be packaged in OpenSatKit that makes sense. That was kind of where that was going. So next slide. So now what? So this is where I want to change the use cases a little bit, or at least introduce them, because now, you know, a person downloads it, they might be just staring at the screen saying, I don't know what I want, you know, what do I do with this thing? So if you could do the next slide, thank you. So here are the same 4 things I put in the agenda. So if you say, I want to learn the OSK or the CFS, you know, from a high level, develop a system, package, distribute. Let's go. I want to walk through what's there now and see, you know, where things are covered and aren't covered and where we might want to go as a community. Next slide, please. So say I want to learn OpenSatKit, and on the CFS, they're kind of, you know, interrelated. So at that first screen in the first tab, in the, you know, the top section there's Learn OpenSatKit. There's drop downs, so then you can actually get access to the videos. There are quick start slides. Some of the actual PDF type documentation might not be as you know, I've been actually leaning towards the videos and PowerPoints to get quicker, you know, a better type education. Then to learn the CFS, it's the same kind of way. There's again, these are at the top level, introductory level. Then at the bottom row there's a section called Core Flight Executive. And each of those buttons will launch a screen for each of the services. And then each of the services has access to features. Next slide, please. So here's showing on the left is event services and on the right, executive services. And it's so at the top section, you can get to every ground command and display every packet. And you could do this in Cosmos in a raw sense, but this is just kind of user-oriented and grouped to what you want to focus on. And like the display file commands, those are commands that might actually generate a file on board. So this command will run a script that then does the command, transfers the file, then just opens up Cosmos Table Manager to display a binary file. Then there's tutorials, and then sometimes there's functional screens that also, like on the right side, that are dedicated to a specific task. Next slide, please. So if you could start this video. So this is a video, and I'll just talk over it. I left the sound off. So in the middle, here's the executive service screen we just saw, and it's going to run a demo. So this is Cosmos Script Runner, and this is a demo with Performance Monitor. So it's going to step through setting up Performance Monitor. And so Performance Monitor is a tool in executive service where you can put markers and trace your code. So the first thing you do is you set up mask, and then you got to trigger when you want to trigger collecting those data points. Now, when I'm circling there, you can actually say the triggering started. You can see the count starting to count up. And one thing I didn't mention, so people on the bottom right, that's actually a CFS terminal window. So the CFS is running down there. That's the UART printing out, or analogous to a UART, printing out your event messages. Now this tool is actually collected the data, downlinked the data, and ran the Core Flight or the CFS Performance Monitor tool for visualization. So the point of that was not to obviously teach it all, but it's trying to show you the pieces. So that's the point of this, is it's end-to-end tool integration. And even if you're not using OSK for your development, at least all the information there that you need to know is captured in a Ruby script that gets you through the scenario. Next slide, please. So here's the second use case. Develop a CFS-based system. So in the blue, I put like the context in a spacecraft. And this doesn't go through everything like hardware in the loop. So I'm still mainly talking software only at this point. So, you got your system level activities with ops concepts and requirements. Then you go through and refine requirements, develop algorithms. And obviously this isn't all iterative. I mean, this is iterative, not just sequential. But when you want to do your development, you got port to CFE and develop custom platform software, which Alan Cudmore gave a great talk the other day. OSK in its current form does not deal with this layer. Although I think the YouTube channel would be a great place if we could do some kind of tutorials or things like that of porting to some common platforms. And that gets back to the value proposition. Kind of, I don't know if I mentioned this in the earlier slide. As a community, to get the apps more valuable, we need more platforms, and to get the platforms more valuable, the more apps we can have, and the more exchange we can have going on in system integration. I think it'll be kind of a win-win there. So back from an OSK point of view, you either develop custom apps, or you can, or you're selecting it for your community apps. And then you got to integrate and verify your flight software. And meanwhile, on the side there's a system level engineering activity that goes along with that. And some of that is, knowing what apps are there in a community and how would I configure them using, and do they meet my system requirements? And then you go on to spacecraft integration and tests and operations. One thing I obviously don't have here is, now I said it's an educational platform, and this is where kind of it's an identity crisis right now. If OSK, it's really an educational platform, then you really wouldn't be using it for your development, because now you got to transfer your database of command and telemetry and all your table definitions and get them to the operational system. One path to this might be, for NOS3, which has been mentioned. But right now our databases aren't, even though they're both in Cosmos, are not compatible. We need an exchange language where we intermediately translate them. But that might be another workflow from a community sense that it's of interest to people. to have something like this as the development environment. It's a little simpler than NOS 3, but then you have a transition path to the operations. Next slide, please. So now these are sub use cases or whatever, sub steps of the initial use case. And I really just put them in there for completeness. I mentioned this is the platform development and development custom software. So right now there's no OSK support. And like, as I mentioned, it'd be nice to have some tutorials. Next slide, please. Excuse me. So from a system engineering point of view, now we're back to the first tab. There's the SimSat drop-down menus, and those can be used to get to SimpleSat, some overview charts. There are some functional and integration tests and ops example tests, but these are very they're skeletons right now. But you know, continually trying to flesh them out. And then in the middle section, and this is the area where I think it's really helpful for the CFS community apps, at least the NASA Goddard ones that have been released. There's application groups. So kind of next slide, please. Next slide, please. And actually, we'll skip this one. This is SimSat Overview. Next slide, please. I realize I'm going to be a little tight on time. So from an application group, what I've done is taken each of the open source, well, actually all the green ones are OpenSatKit apps, and all the blue ones are the Goddard, NASA Goddard apps. And what I've done is group them in the logical groups that help meet a mission's functional needs. So for example, on the bottom left, there's the runtime environment apps, and that includes the scheduler, command ingest, and telemetry output. And these are nice ways of doing a video that can introduce how these three apps work together to provide like a runtime. And then there's the data file management apps, which is just the screen that's showing. And this is kind of similar, same layout kind of with the core the flight executive services. You have access to all the apps, you have some learning resources, and there might be functional screens like managed tables or managed files that help you get a particular task done. And I realize this is all clicking and navigating through GUIs, but there is a scripting environment in Cosmos, and that's another area where scripts are being, at least the demo scripts, each time I do a YouTube video, I've been trying to enhance the, like make a demo script that goes along with a particular video. And that way people can just launch a script, which is much easier than trying to just clicking around the system. Next slide, please. Actually, is it possible to scoot this video maybe in like a minute into it? I don't know if that's actually. So what this video is doing, that's fine. Yep, that's great. That's so what it's doing, it's running a script, and this is a data file and data management video. And so the picture on the screen shows housekeeping, data storage, the instrument simulator, CFDP running. And right now what's happening, it's showing that its first step was, I've actually got a script or screen driven. So you can start collecting data. So you can see the files starting to accumulate. You can see the recorder down there second from the bottom, and you can see the current files being generated. And it's got stats on all the different, just some key stats. So the user controls this whole simulation. So first you start it, then you wait for files, then you select your playback options, CFDP in this case. You select your telemetry rate, which I will be honest, that configures a telemetry output filter table, and that particular table is not tuned properly. So you can ignore those rates for right now. But what we just saw really quickly, but then CFDP did the whole transfer down. And so again, the point here was really just to show you that there's end-to-end functionality that keeps being added. And this is a way to actually see the CFS apps in action, so you can get a real sense of what they can do for you. Next slide, please. So developing a new app, this is a little complex, busy, but I'm the highlight here, I'm just going to go to the lower left and mention that there's CFS style apps and there's an OSK framework app. And so I've developed my own little framework, and then there could be other apps, frameworks. So like I mentioned, WindHover, and that's a distribution. They have their own way of running. So if you're working this workflow kind of is a superset of OpenSatKit. So really, you select the style you want, and you'd want to design and code those apps with requirements in the algorithms and ICDs being driven from that path in the system. And then you're going to verify your new apps and then integrate and go on to the other workflow. Next slide, please. So I kind of jumped ahead. Okay. So from an OSK point of view, there are code generators for the CFS user style app and the OSK framework. But often, just to let people know, the initial app development, Cosmos is there. That's more once you're integrating your app and creating a system and running integration tests. So a lot of times it's not often easier just to cut and paste an existing app that's close to what you need. But I still, offer the app generation tools. And in terms of verifying new apps, OSK does not augment CFS unit testing framework at all right now. Right now, I've been kind of waiting actually for the latest release of CFS and want to adopt more at the unit level, the integration and make it more integrated with the unit testing. And in terms of functional testing and system integration, as I mentioned, I have those the SimSat, kind of the skeleton ones, and I've done some minimal code stuff on top of that, but nothing really extensive. Next slide, please. So the framework I wanted to mention, it's like right now, it's not unit tested. So right now I've been using it more as a technical prototype. And my initial motivation a couple of years ago was I really wanted text-based tables. So, and that was simplifying if I wanted to integrate any of the green apps in OSK. It was a lot easier if I could just have JSON tables, edit them directly, and easily get results to screens when I dump tables and displayed them. So it really made for a nice environment. The framework is written in C, and I did like an object-based approach. And the reason I'm mentioning this framework is, I don't know if anybody ever would want to adopt it for flight and verify it, but it's more about, I started to explore too about packaging apps and how we might want to start talking about if we want to make an app spec for how you package and distribute apps. So I was also playing around with those ideas. So this was more exploratory work. And then within this framework, it's got this, like I mentioned, it's object oriented, but in C. So it's kind of the model view controller design pattern. So the app main is the controller I would view, and then an app is just an assembly of objects that make up that. So it's more an aggregation model, and there's no inheritance. So I don't try to mimic any of that. So what I did with that, once the framework, I did actually take File Manager and I refactored it. And part of that refactoring was to change, just to see what happened if I took the platform configs and put them in the initialization runtime file, and just see which ones were amenable to that and which ones weren't. And so the table at the bottom shows you that it had 32 original compile time configurations. And after I refactored it, most of them ended up in the initialization file. There's only 3 structural pound defines that affected data structures. Everything else could actually be just done at startup. Now, obviously, there's trade-offs about risk, security, and in terms of robustness of the system. But there's also things like, if you wanted to run unit tests with different configurations, you don't have to rebuild anything. You can, or there's just, if you want to move this app and reconfigure it to run in this environment, you just change the initialization file. And the other notice is the code size was almost half as much. Now I have the luxury of having a working app and then refactoring it and really analyzing a working app. But part of that was also due because the framework itself has a lot of functionality that the app doesn't have to worry about. And I see I'm running a little tight. So next slide, please. I'm not going to get this, just shows a little bit of the framework base. Next slide, please. Now selecting and configuring CFS community apps. So next slide. So we'll hit on Discover. So in terms of currently, SimSat, like I mentioned, the system engineering videos are going to be the best probably for understanding groups of apps and how they work. And I'm going to go to the next slide. The next 3 slides are actually just summaries of what's in OpenSatKit right now. So here, this slide is all the NASA open source apps that are in there. And most of them are, you know, if you see like a part in the column 3, I don't have all SBN or CFDP defined in it, but they're not part of SimSat. So, but all the SimSat ones are fully defined, and I've been slowly working through videos. Next slide, please. Then here's SimSat custom libs and apps. These are OSK apps in SimSat. Next slide. We're really gonna. These are additional libs and apps that are actually compilable, but they're not started part of the startup. Next slide. So packaging and distributing. So I've mentioned I'm just exploring some ideas. Some plans are to really look at the CCSDS electronic data sheets, and Joe Hickey, his tool extensions to the Glenn Research EDS Lib has been mentioned. And I really want to look at that as a way to package and possibly describe and integrate apps. Next slide, please.
All right, Dave, can you wrap up in a minute?
I can. So we'll do this. Actually, can you hit the play button? All right. You know what? I had a little timer here and I started late. So I guess I'm thinking this might have to be my minute. Okay. So what this is showing in the app dev, I actually have an add app, and unfortunately we'll have to skip the last 2 sections. So this menu was actually dynamically created. And so it's looking at what's running, what's defined with some meta JSON files in OSK. And I've selected the MQTT app, and that's actually an app for Internet of Things. It's a lightweight transport mechanism. And thanks to Alan Cudmore, I used his prototype. And what just happened, I loaded the app. So the app was compiled locally. So the object file was sitting around. So now it's installed. HiveMQ is an MQTT broker, and MQTT uses topics, and there's a hello world. And so this is going through a broker, and it just popped out on the other screen. So, okay, next slide. So I guess I might out, Chris.
Yeah, if you could wrap it up.
Yep, my last use case was education. Next slide. And I'll just show a picture. Here's a PySat with Alan's PySat and his protosat. And this is not quite working out of the box, but that's an area I want to go to. So I'll stop there. Sorry.
Right. Thanks a lot, Dave. And
right.
It did generate some good Q&A, but I think we'll have to bring that over to Slack, and we'll drop that right in the talks channel.
Okay. Thanks, Chris.
Sorry. Thanks a lot, Dave. No problem. Excellent talk. Appreciate it.